All paper starts out as a mixture of fiber and water that we call pulp. This pulp is applied to a continuous fabric on the paper machine, where it's transferred onto the fabric and then off onto additional fabrics where it's dried to create a sheet of paper. Before the fabric returns to accept more paper, any paper particles that are left behind need to be cleaned off. That's what the shower bar is for. It applies water to the fabric to knock off any particles that have been left behind by the sheet.
Right now, the fabric isn't getting clean enough for the machine to run properly. Let's take a look at the system to see what we can adjust. I know that the nozzles spray the fabric with single coverage, meaning that no spray from any nozzle overlaps the spray from any other nozzle. I also know that the nozzles spray water at a 45-degree angle, and they're each separated by 3 inches center to center. How far away is the shower bar from the fabric? Using what we know about trigonometry and right triangles, we can solve this problem. The answer is 3.6 inches.
The shower bar has the capability to move further away from the fabric. Maybe if we increase the double coverage on the fabric, we'll see better cleaning. How far away do we need to move the shower bar? Using the same principles, we find that the shower bar is 7.2 inches away from the fabric to achieve double coverage.
All right, I think we can make that adjustment, but we might have to turn up the water pressure too. The jets aren't hitting the fabric hard enough to remove all the debris. Let's try increasing the pressure from 80 psi, or pounds per square inch, to 100 psi.
We can do that, but at 100 psi, each nozzle consumes 4.5 gallons per minute of water. The shower bar is currently designed to handle 10 feet per second of water velocity inside the pipe. If we increase to this new capacity, we have to make sure that the water velocity does not go over the design limit.
Okay, well I know that there are 90 nozzles on the shower. The outside diameter of the pipe is 4.5 inches and the thickness of the pipe is 0.25 inches. If we change from 80 psi to 100 psi, what will that do to the velocity of the water?
Hey, so I figured out that velocity question on the shower bar. Turns out the shower bar is using 405 gallons a minute, and we converted that to 0.9 feet cubed per second. We then divided by the area of the inside of the shower bar pipe and found that the internal velocity of the water is 10.3 feet per second.
10.3, that's over our limit of 10 feet per second. Can you help us figure out how many gallons per minute per nozzle will be acceptable to keep us under the 10 feet per second limit?